Propulsion continues to be normal.
The chamber pressure looks good.
Doubling up. Roger, roll, planet.
Water towers can fly!
Yes!
Tango Delta nominal.
Flight Astra, SCE off. Again, SCE off. Off.
Yikes. You bet. Concur. We don't need any more of these.
Good morning, everyone, and welcome to today's live launch coverage. You are looking live at Space Launch Complex 46 at the Cape Canaveral Space Force Station, where Astra is just under 30 minutes away from conducting today's launch attempt for the first in 3 flights for NASA's TROPICS mission. We are coming to you live today from Astra's headquarters in Alameda, California. My name is Thomas Burkhart, News Director for NASA Spaceflight, and today I'm joined by Amanda Dirk-Fry, Senior Manager of First Stage and Engine Production here at Astra. Amanda, thank you so much for joining me this morning.
Great, so excited to be here.
Astra and NASA Spaceflight are once again partnering to bring you today's webcast, so thank you to Astra for helping make this all happen. Over the course of today's broadcast, as usual, we'll be taking as many of your questions as we can. So if you've got a question about today's flight, please tag us with @NASASpaceflight in chat. We're going to try to bring as many of those in as we can. To start off, let's get a status update on today's countdown. Amanda, where are we in today's launch attempt?
Well, right now the weather is looking good for the first beginning of our window. However, it will start to deteriorate quickly due to thunderstorms that are starting to roll in. However, for now, we are still proceeding with today's countdown. As Thomas mentioned, today is the first day of our launch window for LV0010. We are back down at Cape Canaveral, where the vehicle is stationed at Space Launch Complex 46. We have 2 days in our launch window, with tomorrow as our backup, should we be unable to launch this morning. There are many factors that do influence when a launch can or cannot happen, many of which are entirely out of our control. These can include weather or third-party activities, or even aircraft or boats that are getting too close to our launch site. And our team will not launch if these conditions are not optimal. So we are excited to potentially launch this morning, and should we be delayed for any reason, we will of course provide updates on Twitter @Astra. We would like to also extend a huge shout out and thank you to our partners who helped make the launch of LV0010 happen. These include our partners at Space Launch Delta 45, NASA, MIT Lincoln Laboratory, and the FAA, all of whom have been wonderful to work with, and we truly appreciate their ongoing support. And of course to all of our Astra team members and their families. Thank you to our entire team for their dedication to the mission and for helping us get back to the pad once again.
As we mentioned earlier, today is the first flight of 3 in support of NASA's TROPICS mission, and we've got a video to highlight the partnership between Astra and NASA on today's flight.
A Pew Research poll showed that of 9 different categories that NASA should focus on, number 1 on the list is to observe the Earth's climate. The TROPICS mission is a mission that Americans really care about because it is directly observing our climate.
TROPICS has a very specific need for their orbital configuration. We need to go to a 30-degree inclined orbit, and no one else really wants to go there. The ride shares are all going to sun-synchronous orbits or mid-inclinations, so it's very well targeted to a smaller vehicle with a very targeted insertion where they can get us exactly where we want to go, and Astra is perfect for that.
And so being able to launch 3 different times for $8 million is unprecedented. Because of our unique ability to get to 3 different orbital planes in a very short period of time at a low cost.
Why I'm excited about TROPICS is coming out of NASA, having the opportunity to fly satellites for the organization I used to work for is personally gratifying for me. It's also a really important mission because we can detect tropical storms, we can help people evacuate, we can save lives, and it's a mission that's really well designed for Astra's capability, being able to put multiple rockets up into multiple planes rapidly.
And we have the honor of being the final and most important piece at this moment in time of their mission, which is get that hardware in space, exactly where it needs to go. We see that there are increasingly smaller satellites that are smarter, that are doing cool things in orbit, but they need to go to particular destinations at particular times.
The real end game here is improving our ability to forecast tropical cyclones. What we're trying to do is make measurements in the microwave wavelength region, and those have the advantage of being able to penetrate the cloud tops and see the storm thermodynamics underneath the clouds. We're going to get something we've never had before in the history of weather satellites, which is revisit rates of better than 1 hour.
For the team itself, this will be a massive culmination of the last 3 years of work of developing this launch system to be able to do these things that we set out to do from the very beginning.
From Astra's perspective, it's really important because we believe in space at scale. And to do that, you need to have much more frequent launches and access to space. And so this has been an opportunity for us to really understand how can we further compress the turnaround time between launches, both in terms of building the rockets and in conducting the launches.
What this milestone means for us is delivering a really important mission for our customer, but also demonstrating a capability that others can leverage in the future.
And so the opportunity to be a part of something like TROPICS, where you get to make a difference and make a really large impact in the lives of people and help humanity as a whole, does mean a lot to me. And it really excites me as well, going into this mission, knowing that we can help do something to make the world a better, safer place for people.
So Amanda, why don't you recap for us what the goals of today's launch are?
Right, so LV0010 marks Astra's second mission with NASA, and it is the first of 3 launches to deliver the NASA TROPICS satellites to low Earth orbit. Our objective for today is to successfully deliver our customers 2 identical CubeSats to an orbit of 550 kilometers at a 29.75 degree inclination relative to the Earth's equator. They are about 3U in size, which means each one is about the size of a loaf of bread. So pretty small CubeSats, and if all goes well, we should be able to see one of our 2 payloads deploy through our onboard upper stage cameras, yet it is possible that we will not have confirmation for up to 90 minutes, or at least a couple of orbits, as the satellites pass over their ground networks. This is not unusual, since it is due entirely to where the satellites are located within their orbit at the time of deployment relative to their corresponding ground communication links. So we will end the live broadcast shortly after payload deployment, and ask that you follow on Twitter at NASA Earth or at NASA_LSP for confirmation of satellite communications. Astra will also share from our Twitter handle as soon as we have confirmed with our partners at NASA.
Before we go any further, we also want to recognize Dr. Gail Skafronik-Jackson. She was the program scientist at NASA headquarters for the TROPICS mission and sadly passed away in 2021. Her focus area was weather within the Research and Analysis Program of the Earth Sciences Division under the Science Mission Directorate. And we have a video in honor of Dr. Skafronik-Jackson to show here.
There are many, many reasons why I will miss Gail. For her friendship, for her leadership, her science and her driven nature, and really just for her thoughtfulness as a person and as a scientist.
I worked with Gail on the communications for the GPM launch, and she was always so wonderful to work with. I feel like I really learned how to, communicate what we needed for telling great stories about the satellite. And I remember just how she lit up when she was talking about it.
So you can see these small scale systems at a resolution of about 10 kilometers by 10 kilometers. That's about 6 miles.
She was just excellent to work with, just on all levels, an outstanding friend, a great person to talk to when you had problems, always willing to listen, and I'm certainly going to miss her dearly, as I'm sure everybody else will.
She was a tremendous scientist in the field of snow remote sensing. She led GPM to its success, working with a multidisciplinary and diverse team. And she worked to encourage and expand our team and being mindful of diversity and inclusion within the GPM and the broader program.
She leaves some very big shoes to fill, and she has provided a stellar example of how we should be carrying out science and getting the work of NASA done.
So thank you to the NASA and Astra folks for their partnership on today's webcast, and of course recognizing Dr. Skafranik-Jackson there. We're going to go ahead and get into some questions here. We're about T-minus 19 minutes and counting. Everything appears on track so far for the opening of today's window. Of course, the focus of any launch is the payloads that are on board. So our first question here from Carson is, are these satellites CubeSats on board today's flight? Amanda?
Yes, the satellites on board are are CubeSats. They are two identical 3U CubeSats that contain a dual-spinning radiometer and a compact microwave spectrometer. The purpose of these are to penetrate through the cloud layer of developing or active storm fronts and provide near-hourly imagery of a storm's progression, including data on precipitation, temperature, and humidity. So these CubeSats will help scientists and meteorologists to understand how storms form, grow, and intensify throughout their life cycle, helping them to better detect and understand tropical storms better. NASA has an incredible mission overview about these small satellites that you can find a link to at astra.com/mission/tropics-1.
Awesome. And of course, today's flight is the first of 3 missions for the TROPICS program. There are 2 satellites on board today. 6 satellites are planned in total across the 3 flights, all launching from here at Cape Canaveral. Today's first flight on schedule so far. Again, if you're just joining us, the launch window opens at 9 o'clock a.m. Pacific time or noon Eastern over at local time and Cape Canaveral, which is just under 18 minutes away from now. Keep the questions coming in chat. If you've got them, we'll try to answer as many of those as we can. One of the questions we're seeing in chat here is, where is Carolina today? Of course, we've seen Amanda on the coverage before. We've definitely interviewed here before, but first time hosting, so congratulations, Amanda. I do believe we do know where Carolina is today, though.
Yes, yes. So she's not here for a very great reason today.
There are many, many reasons why I will
Friday
miss
on
Gail.
June 3rd. So Carolina and family are at home resting and recovering, very well deserved. So huge congratulations to her from our entire Astra family. But yeah, so she is at home right now, enjoying and cheering on Tropics from at home.
Awesome. So congratulations to Carolina and her family, of course. Some other questions coming in here. I've got one saying, how much does a rocket weigh, Amanda?
How much does it weigh? So the vehicle weighs approximately 2,400 pounds when it is dry. So that is just the dry weight of the vehicle, which doing a quick Google search before this did find out that that is roughly the weight of an unfueled Toyota Yaris. And then we do add about 2,400 pounds worth of propellant to the vehicle. So in total, we're looking at around 26,000 pounds, 24,000 pounds of propellant. So doing some back of the envelope calculations, that's about the equivalent of a Toyota Yaris carrying around 4 female elephants. And another fun fact that our engineering team likes to share about the vehicle is that the wall thickness to diameter ratio of the rocket is actually similar to that of a soda can.
All right, there you go. Thank you to Judah for submitting that question to us here. Let's see. So again, 15 minutes to go here. Everything on track so far. We'll keep some questions coming. Mitch Bunks asks, is this an instantaneous launch window? I believe not, right, Amanda? We have a 2-hour launch window, I believe, today?
Yeah, today's launch window is 2 hours. As we mentioned at the beginning, there is a small window at the beginning where the weather does look favorable. However, there are thunderstorms that are rolling in, so the weather will continue to quickly deteriorate as we move into our window this morning.
Got it. We'll keep an eye on that. Of course, if there are any updates regarding the weather, we will happily provide those, but count proceeding towards the opening so far. Let's see, some other questions here. We talked about earlier, Brett asking what direction is this launch going. So today's target orbit is a 29-degree inclination just about, which is pretty much due east from Cape Canaveral. We actually saw a graphic earlier showing the launch trajectory zones going east of Cape Canaveral. There it is. That is the path the rocket is planned to take, east of Cape Canaveral towards that orbit. That's actually why this mission is launching from Cape Canaveral. It's because it's targeting that sort of mid-inclination orbit, which is different from Kodiak, where Astra also launches, where that's more favorable for polar launches or sun-synchronous launches. So as you can just see, the countdown is just held at T-minus 15 minutes, so we're going to go ahead and look for some more information on that. We'll provide an update as soon as we have it.
Tango on countdown, GNC setup is complete.
And Tango and AV1 manage pulling. Please toggle do both ground and guidance pulling to put the vehicle back in its nominal state.
AV1 manage pulling, do both ground and guidance. Set to true.
Per step 69, Delphin, can you confirm that the Delphin system looks ready for launch?
Delphin confirms good for launch.
Step 70, Orbit, can you confirm the Ether is ready for launch?
Ether's ready for launch.
Tango, in machine Aux1 ISO control, set high pressure target to 90 psi.
Aux1 ISO control, high pressure target, 90, enter.
Step 72, Tango, verify vehicle looks okay for launch aside from tank levels and pressures.
Inward. Confirmed, vehicle looks good.
And step 73, GNC, confirm wind profiles are still acceptable for launch at this time.
Confirmed.
Okay, this takes us to our water test, step 74. Tango, in Water 1 water system, toggle prime to true to begin flowing water up to the deluge system.
Water 1 water system, prime to true. Path open.
So while teams are working to resolve this hold at T-minus 15 minutes, and again, we'll provide updates as soon as we have them, we do have a couple more questions coming in. So let's start with this one from Don, which asks, what is the thrust of this rocket, Amanda?
So the first stage of the rocket has a total combined thrust of 32,500 pounds to lift us up from the launch pad, and then our upper stage has 740 pounds of thrust.
And what fuel combination is producing that thrust?
Yeah, so we use the same type of fuel propellant on both the first stage and the upper stage, and so that is a combination of liquid oxygen and RPX, which is a highly refined form of kerosene.
Gotcha. And so those fuel and engines are all on the Rocket 3 vehicle that we're looking right now. John asking what rocket is TROPICS 1 sitting on. I believe even specifically it's Rocket 3.3, but can you give us just an overview of the launch vehicle that is launching today?
Yeah, so Rocket 3 is a two-stage launch vehicle, and here you can see in the expanded diagram, you can see all the major sub-assemblies of both the first stage and the upper stage. So we could step through them one by one. So starting at the aft end, which is the far left side of the diagram, you see the first stage engine bay. And so on the engine bay, there are 5 electric pump-fed first stage engines. Each one provides around 6,500 pounds of thrust. So as I said earlier, for a total of 32,500 pounds to lift the rocket. And surrounding the engine bay is some thermal protection, mostly just to protect the engine controllers and onboard computers from the high heat environment during launch. Moving towards the forward end, you see the large cylindrical section there, which is the first stage propellant storage. And so that is a fully welded structure that's fabricated here in-house in Alameda. All those sheet metal components arrive as rolled sheets of aluminum, and our first stage production technicians perform a longitudinal friction stir weld up each seam before sequentially joining each one together via circumferential TIG welding operations. And that is how it forms the fuel and liquid oxygen tank. And you can actually see some really great videos and images of our team at work on these exact operations by searching #FactoryFriday on LinkedIn to see some of our posts. And although the tank looks like one large volume, it is actually split into 2 separate tanks. One is for the RPX, which is that highly refined form of kerosene, and that one sits closest to the engine bay, and then liquid oxygen. And you can see the delineation line between the two as the liquid oxygen tank forms that thin layer of frost on the exterior due to the cryogenic fluids inside. And so you can see that on the live video feed of the rocket over on the right-hand side there. Continuing our way towards the forward end, that conical section is called the inner stage. And that's what houses many of our onboard avionics components. There's radar on there, antenna, even some cameras that look down the length of the first stage during flight. And again, this is a fabricated sheet metal assembly, and it does have additional structural supports in there, as that is how the upper stage is secured to the first stage during flight. And that takes us to the upper stage, which is that assembly that looks like stacked spheres on this far right side of the image. The upper stage also uses RPX and liquid oxygen as its main propellants, and that one has a single engine, which is pressure fed and can provide 740 pounds of thrust. The upper stage gets nestled into the inner stage during flight until main engine cutoff, when the first stage releases the upper stage for its final segment of flight. And if you look back at the first stage tank, you can see on the LOX dome those fingers that are sticking out. Those fingers actually do help to support the upper stage engine during the high vibrations during the first stage portion of the flight. And then lastly, we have the fairings, which are those 2 clamshell structures that go around the upper stage and payload and protect it during flight. And then those will pop open just after main engine cutoff for release of the upper stage. And then if you do see on the right-hand image, the the inner stage and fairings are also white, but that is not due to the similar frosty effect of the liquid oxygen tank. Those have a thermal protection on them to protect the payload from the aerodynamic heating that is caused by the compression of air as the vehicle moves through the atmosphere. So that is Rocket 3. Overall, we're able to deliver 25 to 150 kilograms to a 500-kilometer sun-synchronous orbit with this vehicle. And a majority of these parts are produced here in-house in Alameda. I would absolutely love to give shout-outs to every one of the technicians and engineers that help us build these vehicles. Yeah, we are on the clock this morning, so as I mentioned, please take a look at #FactoryFriday on our social media sites, where you can see some of our technicians at work building all the various structures of this vehicle. And if you've not also seen it before, please be sure to check out the factory tour that NASASpaceflight took with our Vice President of Operations, Bryson Gentile, last year. It's a great look at some of the incredible things our production teams are building here in Alameda.
Absolutely. I'm looking forward to version 2 of that factory tour, because the factory has changed a lot since that video
as
well. So looking forward to maybe revisiting that as well. We do have a brief update on the hold. Again, we're holding at T-minus 15 minutes and is now confirmed. The hold is due to some boats in the safety hazard area. So we'll provide some updates as the range and the Astra teams work that issue. In the meantime, we'll happily take some more questions. So again, if you've got questions about today's mission, please test with @NASASpaceflight, and we're trying to bring as many of those in as we can. We are keeping an eye on the weather as this hold continues, hoping to get this resolved as quickly as possible, of course. But let's see what other questions we have. Here's a good question. Amanda, is there any particular reason that this hold is happening at exactly at the 15-minute mark, or is that just kind of a convenient time? No particular reason. We'll keep providing some more updates as we have them. But again, if you have any questions, please tag @NASASpaceflight in chat. In the meantime, let's go ahead and listen into the pad microphones as the teams work this issue, and again, we're going to wait for another update as we have them.
Astra flight on countdown. We have cleared the final clear to launch pole. New T0 is 1612 UTC. Step 80 Tango in AB1 managed power systems. Toggle ground power system authority to true.
Ground power system authority true.
In AB1 managed polling, toggle do both ground and guidance polling to true.
Do both ground and guidance true.
GNC, do you require an additional self-test at this time?
Yes, please.
In VB1 turn on off PDBs, Tango, please toggle GNC self-test to true. GNC call out upon completion.
Okay.
GNC self-test started.
GNC self-test passed.
Copy. FTS, can you confirm that the FTS is still enabled?
Safety can confirm.
Copy. Tango and Fuel 4 operate. Please toggle full and fast to true.
For operate full, true.
Alright, so as you may have just heard, we have a new T0. The countdown has resumed, just under 11 minutes to go. The new T0 is 9:12 a.m. Pacific time, or 12:12 p.m. Eastern time, 16:12 UTC. The range has cleared that boat in the hazard area, and everything now on track for launch in just under 11 minutes. So we should be now coming up on the go, no-go poll for today's flight. So let's go ahead and listen into the countdown as the teams work through the final 10 minutes of the count.
Currently not in idle.
Please set to idle.
Setting to idle. Idle.
Please set Fuel 4 operate to idle. Or sorry, standby on that one. Please make sure pump battery 2, manage pump battery charge is in idle.
Go.
Tango in 0, machine activator, toggle launch machines to true.
0 machine activator, launch machines to true.
Tango, activate launch machine.
Launch machine is active.
Toggle locks topping to true.
Lock stopping, true.
This takes us to step 90. This is the poll for tank pressurization and launch. Payload, please confirm there are no concerns for flight and that the payload is ready.
Payload ready.
Copy. Astra team, after this point any system issue must be called as a hold on the countdown net. If there are no concerns for flight, call go, otherwise no go. Red lead.
Red lead is go.
FTS.
FTS is go.
GNC.
GNC is go.
Athena.
Go.
FAO.
FAO is go.
CDH.
CDH is go.
Tango.
Tango is go.
Astra safety.
Safety is go.
Flight is also go. Tango, verify that the vehicle still looks ready for launch aside from tank press and final topping.
Confirmed. LCCs are met.
Alright, so the teams have pulled go for today's launch attempt, under 7 minutes to go. Really quick, let's go ahead and preview what we're expecting to see in just under 7 minutes. Amanda?
Yeah, so at T-0, the first stage engines will fire at the full 32,500 pound thrust to start LV0010's journey towards space. Just 6 seconds into the flight, the onboard guidance will start to pitch the vehicle over towards its orbital trajectory. And just over 1 minute into flight is where the vehicle will reach max Q. This is a really important milestone that tests the structural integrity of the first stage body during flight. It is the period of maximum aerodynamic load on the vehicle. At the 3-minute mark, we will have reached main engine cutoff, or MECO as it will be called out, which is where the first stage engines will receive the command to shut down, allowing the vehicle to briefly coast before stage separation. From there, we have a series of 3 closely timed events. The fairings will pop open and fall away from the vehicle, immediately followed by stage separation, which is when the first stage releases the upper stage into atmosphere and concludes the first stage milestones for the flight. And just around 3 minutes 15 seconds, the upper stage engine will ignite and be on its way to delivering our customer's payload to orbit. After a roughly 5-minute flight, the upper stage will receive the command to shut down its engine, followed by payload deployment. As we mentioned earlier, we are hoping to see one of the 2 payloads being deployed through the upper stage onboard cameras. However, it is possible that it can take up to 90 minutes or a couple of orbits of the satellites in order to have this confirmed. And that is entirely foreseen. This is due to the nature of the ground links relative to the satellite's location in orbit once the deployment occurs. So we will be ending the live stream broadcast as soon as deployment happens, and likely before the satellite communication has been confirmed. But please remember to follow NASA's Twitter handle at NASA Earth for confirmation once the satellite communication has been received. And we will also provide an update on our handle at Astra when we have confirmed with our NASA partners.
Awesome. And at T-minus 5 minutes and counting, we also should quickly just acknowledge that the new mission control look, which may have looked different from last time. Amanda, you want to talk a little bit about why mission control here in Alameda looks a little different today?
Yeah, so our mission control has gotten an upgrade. A lot of that is trying to improve our operational efficiency and streamline our processes. It used to take 6+ team members, and now we've gotten that down to our 4 key team members in the mission control pod. And these pods are portable as well, so we can perform mission control from anywhere that we need to.
That's awesome. So about 4.5 minutes to go here, and everything appears on track for launch. So with that, let's go ahead and listen into the countdown net. We'll listen to the teams go through the final steps for launch. Of course, myself and Amanda will provide any updates as we have them, but let's listen in as the first Tropics flight approaches liftoff.
Four minutes. Rock, flight on countdown.
Rock.
First step 94, please verify range is recording telemetry at this time.
Telemetry recorders are running.
Copy, thank you. And reminder to control room, if you require RF data, be prepared to switch over your pages at liftoff. Reminder to all that any 3-word hold from here on out is an immediate abort regardless of source. And MIFCO, please be prepared to issue option when rocket IIP marker passes min MECO and is within dispersed trajectories, calling out at event.
MIFCO copies.
ACE, start PSD recordings and downrange ground station recordings at this time.
Will do.
Two minutes.
2 minutes and counting. Everything on track so far.
Hold, hold, hold.
Pulling it apart.
Okay, so as you may have just heard, a hold was called on the countdown net, so we're going to stand by for another update to see what the issue the teams may be working is. We'll provide that update as soon as we have it, but again, the count has entered a hold.
We do have an update for you. We are still holding to complete final LOX conditioning, and so once that is complete, we will likely get a new T0 time shortly from Mission Control for you.
Yeah, we'll keep the updates coming again as soon as we have them, everyone. Holding at T-minus 31 seconds, expecting a recycle for a new T0 shortly. Also, in the meantime, while we wait for that recycle, we'll go ahead and take some more questions. First off, I'll just start with one off the screen. No, that cruise ship is not violating the range right now. That ship in the background is not within the protected launch corridor. It's beyond where the rocket plane trajectory is, so no worries there. But feel the need to adjust that since it's on screen. But otherwise, we've got some other questions to come in while we wait for this hold to clear. So let's start with this one here. Scribs asks, what kind of material is the vehicle made out of, Amanda?
Yeah, so a lot of our first stage structure is made out of aluminum. We try not to have any exotic materials on the vehicle that are difficult to obtain or hard to machine. That really helps to ensure that the vehicle is scaled for manufacturability.
Gotcha. Another question from Sergeant Scott is, how tall is the rocket and is it heading to orbit today?
So the vehicle is 43 feet in length, so it is able to fit into a standard 45-foot shipping container, which makes it very easy for portability to our various space ports. And our launch attempt today is, countdown will be resuming soon, and so once that happens, our targeted orbit for this mission is to deliver the TROPICS 1 payloads to the 550-kilometer orbit at, again, that 29.75 orbital inclination relative to the equator.
Gotcha. Yeah, so on the screen here we can actually see that graphic of the planned launch trajectory. It's pretty much due east out of Cape Canaveral within that kind of safety corridor. And then if we go back to that camera that showed the cruise ship, that's looking south, actually towards Port Canaveral. For those of you that live or have been around the Canaveral area may know what I'm talking about. That is south, whereas the rocket will be flying kind of left out of frame from this view to the east. So again, just reiterating that the cruise ship is not anywhere it's not supposed to be and is not a problem for today's flight. The current hold is to complete final liquid oxygen conditioning on the vehicle. So waiting for a new T0 regarding that as well. But in the meantime, more questions. We do have a funny question here. Musical Wolves, a regular in the chat, who says, are the mysterious 4 towers portable for Astra, since the rocket and ground equipment are portable? I don't think the lightning protection towers are some of the things that Astra ships out, right?
Those are not. That is part of the permanent infrastructure at the Space Launch Complex.
Gotcha. Always got to ask about the towers, though. It's a rule around here. We do have a quick question here from Dag, who asks, when does the launch window close? Today's launch window extends until 2 p.m. Eastern Time, or 1800 UTC. So we're still pretty early in the launch window, and hoping for a quick recycle and a new T0 here shortly. While we wait for another update on this hold, again, hoping that it'll clear soon, but we're going to go ahead and take a break and wait for another update. We'll provide that as soon as we have it. Okay, so as you can see, we're still holding here. We're waiting for this hold to be resolved, but Amanda, I do believe we have an update regarding the weather for today's attempt.
Yeah, so we have recently heard from the range that we are good for another 20 minutes. After then, the weather will become too difficult for us to be able to likely proceed with today's launch.
So yeah, so we'll keep an eye on that, but it looks like we've got at least another 20 minutes to go. So hopefully, if this recycle can occur a little bit quickly, we should still have another chance to launch today. So again, keeping an eye on that, and we'll provide more updates as we have them, as they continue to work this LOX conditioning issue. In the meantime, I think the audio cut out earlier, so I want to ask this question again. Earlier we had that hold at T-minus 15 minutes. Do you want to talk a little bit about why that was the hold point?
Right, yeah, so the T-minus 15 mark is when we enter our terminal count, and that is a really important milestone. That's when we can start to transfer the control over to the vehicle. That's also where we would likely revert back to in case of a recycle. And another key milestone is at approximately 10 minutes from liftoff, where we perform the go pull for launch and tank pressurization. And then at 6 minutes is when the range provides the authorization to launch.
Gotcha. So while we're waiting for this hold, if you are just joining us, this is the live coverage of the Tropics 1 mission on Astra's LV0010 vehicle. Amanda, do you want to just give a brief overview for the new people that may just be tuning in about what today's mission is all about?
Right. Yeah, so this mission marks, again, our second mission with NASA, and we are launching, it's the first of 3 launches to deliver the NASA TROPICS satellites to low Earth orbit. And so the objective for today is to deliver the 2 identical CubeSats to an orbit of 550 kilometers at a 29.75 degree inclination. These payloads are about 3U in size, so they are fairly small, and the payloads are used to monitor the weather of incoming storms. And so the imagery will actually penetrate into a storm cloud layer and be able to provide precipitation, temperature, and humidity data measurements for scientists and meteorologists to help understand how storms form, grow, and intensify throughout their life cycle. And then we do have a great blog that NASA has provided for us. You can find that with a more overview of the satellites themselves. You can find that at astra.com/mission/tropics-1.
All right. And while we wait again for more mission updates, we have a couple more questions coming into the chat here, so we'll go ahead. We got one asking about the spaceports that Astra operates out of. Of course, this is Cape Canaveral, not the first time Astra has launched from here. Astra has also launched from Kodiak in the past. Can you talk a little bit about the differences in those spaceports and where else Astra might begin launching from?
Yeah, so the 2 main spaceports that we launch out of right now are Kodiak, Alaska, and Cape Canaveral. So Kodiak is beneficial because it is a commercial launch site for both orbital and suborbital vehicles. And then we did actually recently announce a partnership in May with Saxavord in UK Spaceport. You can learn more about that partnership at astra.com and also our video recording from our Space Tech Day. So we're very excited about this partnership as it would expand our capacity to reach key inclinations.
Gotcha. And speaking of other locations regarding Astra, where was this rocket built?
This rocket was built right here at our headquarter factory in Alameda, California.
And shipped via road all the way to Florida, right?
Yep, this one rolled via truck.
I believe we actually have a video of that arrival, if we can show that. This is the video of the rocket being shipped out to Florida for today's launch. So again, that's how the rocket got here, and of course there was a static fire test prior to the launch attempt, and today's launch attempt is currently in a hold. We're waiting for another update on this LOX conditioning issue. Once that hold clears, there'll be a recycle point and a new T0. So once we get a little bit more information and an update on that, we'll go ahead and come back, but let's go ahead and take a break, and we will come back to you with more information as soon as we have it. Again, stick with us. Alright, so we are still in a hold here at T-minus 31 seconds, expecting a recycle and a new T0, hopefully before too long. The window does last all the way till 2 o'clock p.m. Eastern Time, 1800 UTC, and we're keeping an eye on the weather with regards to that as well, but still holding for an update, hoping for another recycle still. But in the meantime, we do have some more questions coming in. So first off, Amanda, how much thrust does Rocket 3 have, and what's the thrust-weight ratio with that?
Yes, so the overall thrust of the first stage vehicle is 32,500 pounds. So there are 5 first stage engines on our engine bay, and each one of those deliver about 6,500 pounds of thrust individually, and there's 740 pounds on the upper stage.
Gotcha. And that thrust, again, we talked about earlier about the fuel combination of RPX kerosene and liquid oxygen. Martin is asking, is the rocket propellant, the kerosene component, not cooled? Because you can see only the liquid oxygen tank is frosty there.
Yep, no, the kerosene is not cooled. That is at atmospheric conditions.
Gotcha. Another question here. What is the payload capacity of Rocket 3?
Yeah, so Rocket 3 is able to deliver anywhere from 25 to 150 kilograms of payload up to a 500 kilometer sun synchronous orbit.
Gotcha. And again, the rocket for today's launch still in a hold. We're going to provide another update as soon as we have it, but the teams are hoping to recycle. So keep those questions coming in the meantime. Go ahead and tag us at NASASpaceflight in chat. We're going to keep looking for some more questions while we wait for another update as well, and we'll come back as soon as we have it. Alright, so we're still waiting for an update on today's countdown. Again, we'll provide that update as soon as we have it. In the meantime, let's go ahead and take a look at this overview video about the NASA TROPICS mission in partnership with Astra.
A Pew Research poll showed that of 9 different categories that NASA should focus on, number 1 on the list is to observe the Earth's climate. The TROPICS mission is a mission that Americans really care about because it is directly observing our climate.
TROPICS has a very specific need for their orbital configuration. We need to go to a 30-degree inclined orbit, and no one else really wants to go there. The rideshares are all going to sun-synchronous orbits or mid-inclinations, so it's very well targeted to a smaller vehicle with a very targeted insertion where they can get us exactly where we want to go, and Astra is perfect for that.
And so being able to launch 3 different times for $8 million is unprecedented. Because of our unique ability to get to 3 different orbital planes in a very short period of time at a low cost.
Why I'm excited about TROPICS is coming out of NASA, having the opportunity to fly satellites for the organization I used to work for is personally gratifying for me. It's also a really important mission because we can detect tropical storms, we can help people evacuate, we can save lives, and it's a mission that's really well designed for Astra's capability, being able to put multiple rockets up into multiple planes rapidly.
And we have the honor of being the final and most important piece at this moment in time of their mission, which is get that hardware in space, exactly where it needs to go. We see that there are increasingly smaller satellites that are smarter, that are doing cool things in orbit, but they need to go to particular destinations at particular times.
The real end game here is improving our ability to forecast tropical cyclones. What we're trying to do is make measurements in the microwave wavelength region, and those have the advantage of being able to penetrate the cloud tops and see the storm thermodynamics underneath the clouds. We're going to get something we've never had before in the history of weather satellites, which is revisit rates of better than 1 hour.
For the team itself, this will be a massive culmination of the last 3 years of work of developing this launch system to be able to do these things that we set out to do from the very beginning.
From Astra's perspective, it's really important because we believe in space at scale. And to do that, you need to have much more frequent launches and access to space. And so this has been an opportunity for us to really understand how can we further compress the turnaround time between launches, both in terms of building the rockets and in conducting the launches.
What this milestone means for us is delivering a really important mission for our customer, but also demonstrating a capability that others can leverage in the future.
And so the opportunity to be a part of something like TROPICS, where you get to make a difference and make a really large impact in the lives of people and help humanity as a whole, does mean a lot to me. And it really excites me as well, going into this mission, knowing that we can help do something to make the world a better, safer place for people.
Alright everyone, again, we're still waiting for an update on today's countdown. The window does last again till 2 o'clock p.m. Eastern Time or 1800 UTC, so we'll provide an update as soon as we have it. There is still time left in the window, and the teams are continuing to work to resolve this hold, so stand by for an update as soon as we have it. All right, everyone. Thank you for your patience and sticking with us. We'll keep providing, and we'll provide another update again as soon as we have it. Right now, the teams are just still working to resolve this hold in the window that again lasts for another hour. So plenty of time in the window, but standing by for another update, and we'll provide that and a new T0 as soon as we have it. In the meantime, we do have a couple more questions that we can go through here. So let's see. If today is scrubbed, when is the next likely launch window, Amanda?
Yeah, we do have one more day in our launch window, which is tomorrow, Monday, June 13th.
Right, and we're not pushed to that just yet, but there is a backup opportunity tomorrow. For tomorrow, does the weather look favorable for tomorrow's attempt?
Right now, it does look like the weather is actually more favorable than it is today.
Got it. The weather's still kind of holding out for today, so we're going to keep an eye on that. But another attempt with a favorable weather forecast tomorrow. So again, we'll provide that update as soon as we have it. Other questions here. We do have a question earlier. We were talking about how the teams were working on LOX conditioning. Can you actually elaborate on what that means and what's what they might have been working on with regards to LOX conditioning?
Right, so that's part of our propellant loading procedure. It's filling up the liquid oxygen into the liquid oxygen tank. As the vehicle is sitting on the pad, obviously, since it is a cryogenic fluid, that fluid is boiling off. And so as it sits there, we do need to top off the tank. So we need to continuously refill the liquid oxygen as the vehicle is sitting on the pad prior to launch.
Got it. Another question here from Keynes, who asks, is Astra hiring? I believe that's a great question for you right now, Amanda, right?
Yeah, Astra is hiring. Please check out our website for the over 100 different postings that we're currently recruiting for. And we have an amazing recruiting team, so please reach out to any of them. They'd be more than happy to share with you all of the opportunities that Astra has to offer. I personally spent 11 years in the aerospace industry in test engineering before I took the huge step to join the operations team here at Astra, and it really has been one of the most rewarding experiences. Sending rockets to space is hard, as you can see, and this team works really hard, but they take care of each other. And we aim to give everyone ownership and autonomy over their projects. So come work on something amazing with us. We're looking for mechanical engineers, test engineers, fluids engineers, anyone with experience with valves or automation, or even software systems to help us design our next rocket. And we're also looking to scale up our team in the operations department as well to help us build and qualify each of these vehicles as it leaves the building. So looking for production supervisors, production managers, as well as build technicians. So please check out our website at astra.com/careers.
Awesome. Some other questions we're getting here. We had one question about, have there been any major changes since the last launch from LV0009?
So we are continuously seeking to improve the functionality and reliability of the vehicle. So there have been some minor software updates that have been implemented on LV0010, but there have not been any major material or mechanical upgrades to the vehicle since LV0009. We do have the remainder of our TROPICS vehicles currently in work on the production floor. They're actually directly behind us right now in the final integration lane, and so our team is actually working to transition away from Rocket 3 and towards our Rocket 4. So we did see a question in there about the progress of that. So we are at a transition point right now for our production floor as we're ramping down our Rocket 3 production efforts and building in more of those development builds for Rocket 4.
Nice. See, another question we had was, how long before the launch does fueling take place? Because of course when we go live, you guys just see propellant loading has already been well underway. So how long before launch does Astra start fueling the rocket?
Yeah, so it typically takes about 2 hours to start the fueling process from beginning to when the vehicle is ready to go. And sometimes if we do need to recycle, it can often take up to 30 minutes to recycle the vehicle.
Gotcha. And with regards to that ground support equipment that is, of course, involved with fueling and all these other things, can you talk a little bit about how that ground support equipment gets transported along with the rocket to the launch site?
Yeah, so the amount of ground support equipment that goes with each of the vehicles depends on where we're launching from and what type of infrastructure we already have set up in that area. So if it's Kodiak, Alaska, or the Cape, then we have some of the ground support equipment that is left there from our previous launches. But if we were to set up brand new at a new location, believe we can bring all of our ground support equipment in roughly 5 containers, and that includes our consumables, the helium LOX containers, our fuel. It brings in the cube, and even the cube for the launcher system and the rocket, and then we also have a clean room that we bring along in a shipping container. So roughly around 5 shipping containers is what we need to set up a new space.
5 shipping containers for an orbital launch system. That's pretty cool. Again, everyone, if you just stick with us, we are waiting for another update on today's countdown. Still in a hold right now. The window lasts until 2 o'clock p.m. Eastern Time, and we will provide another update. Again, as soon as we have it, the team's still working on resolving that hold. But keep the questions coming. Tag us at NASASpaceflight in chat, and we'll come back with some more updates and some more question and answers once we have them. All right. Go ahead.
We do have an update for you. We are going to finish our configuration loads and checks and then do a terminal count pre-poll, and we'll be checking back in with the range to see if they are go or no-go. It does appear like the weather is favorable until at least 10:45 a.m. Pacific.
Yeah, so that Florida weather doing the Florida weather thing where it might just hold out long enough, so we'll keep an eye out on that. But sounds like we are getting close to a new T0, so stay tuned for that. In the meantime, we do have a couple more questions to go through, so we'll keep those coming with that update. First question from Hoppy is, what is the expected time for launch tomorrow? I have exams and don't want to miss the launch. I can relate to that. But what is the launch window for tomorrow?
So the launch window for tomorrow would be at the same time as it was today. So that would be starting at 9 a.m. Pacific, 12 p.m. Eastern.
Gotcha. But hoping that we don't need that because it sounds like we might get lucky today. We'll stay tuned for that. Other questions coming in here. Gaming Viper asks, what engines are being used for this rocket? So what are the engines on Rocket 3?
Right, so the Rocket 3 engines, so on the first stage, there are the 5 electric pump-fed engines. Each one has 65,000 pounds of thrust, and so those are fed via the RPX, which is a highly refined form of kerosene as well as liquid oxygen. So there's a total combined thrust of 32,500 pounds on the first stage engine bay. And then there is one engine on the upper stage, and that is a pressure-fed engine that can provide 740 pounds of thrust.
Gotcha. And then you mentioned earlier we were talking about the new mission control setup. That's still here in Alameda, right?
Yes. Yeah. So even though this pod is portable, the intention is for mission control to stay here in Alameda rather than actually transporting these pods to the launch site. Mission control is intended to be at headquarters. However, we do have our smaller team that does head out to the launch site. That is our red team. So the intention is to make sure we have 2 small teams supporting each of the launches. One that does travel to the launch site, but then also the mission control pod staying here and supporting on site at headquarters.
Yeah, I gotcha. So again, the launch site out there in Cape Canaveral, Florida. If you are just joining us, this is live coverage of the LV0010 launch vehicle, which is slated to launch the TROPICS 1 mission, the first of 3 flights for NASA's TROPICS mission from Cape Canaveral, Florida. Right now the teams are in a hole, but they are working on resolving it with some last minute checks and things. Sounds like we should get a new T0 hopefully very soon. The window lasts until 2 o'clock p.m. Eastern, and weather is continuing to cooperate, maybe just long enough for a launch today. But we're going to stay tuned for another update, and we'll provide that T0 as soon as we have it, so stay with us.
Okay, Tango, can you confirm for me that an AV1 managed power systems toggle ground power systems authority is still true?
Tango on countdown, AV1 managed power systems authority, ground power systems authority is true.
AV1 managed polling, do both ground and guidance polling is set to true.
Setting both ground and guidance polling to true.
GNC.
Alright, so as you can see now, the countdown clock has resumed to just about T-minus 12 minutes and counting. We're going to come up on another go, no-go poll like we heard earlier. The teams are back into a recycle and aiming for a new T0 of 10:43 a.m. Pacific time. That's 1:43 p.m. Eastern time, local time in Cape Canaveral, or a 17:43 UTC. Again, now just under T-minus 12 minutes, and the teams are tracking towards a new T0 for today's launch. Really quickly, we can do a brief overview of the mission timeline again. If you are just joining us, this is what we would expect to see after the last 10 minutes of this countdown. So, Amanda?
Yeah, so T0 is when we have first stage engine ignition and liftoff. And then just 6 seconds into the flight is when we begin our pitch over, which is when the onboard guidance will start to pitch the vehicle over towards its downrange orbital trajectory. And then just over 1 minute over into flight is when the vehicle will reach max Q. Again, this is when the vehicle's structural integrity will be tested because this is when it is the maximum dynamic pressure on the vehicle during flight. And just at the 3 minute mark is when we will have reached main engine cutoff, or MECO as it will be called out. And this is when the first stage engines will receive the command to shut down, which allows the vehicle to briefly coast before stage separation. From there, we will receive the command to have the fairings pop open and fall away from the vehicle, which will then be followed immediately by stage separation. And so that is when the first stage releases the upper stage into the atmosphere. And then at around 3 minutes 15 seconds, the upper stage engine will ignite and be on its way to orbit. And then after a roughly 5-minute flight, the upper stage will receive the command to shut down its engine, followed by payload deployment. And as we mentioned earlier in the live stream, we are hoping to see live video feed from one of our onboard upper stage cameras of one of the 2 payloads being deployed. However, it is possible that we will not see confirmation of this for up to 90 minutes after the satellite deployment, or at least a couple of orbits, and that is mostly due to the location of the satellites in their orbit relative to their ground communication links once deployment happens. So we will be ending the live stream right as deployment occurs, but again, the satellite communication may not be confirmed for up to 90 minutes. So please remember to follow NASA's Twitter handle at NASA Earth, who will provide confirmation once that satellite signal is confirmed. And then we will also provide an update on our handle at Astra when we have confirmed with our NASA partners.
As the teams get ready to go into the last few minutes of the countdown, let's go ahead and listen in as they go for the final go, no-go poll.
Okay, team, this takes us to step 90, hole 3 for tank press and launch. Customer, can you please confirm if the payload is ready for flight?
Payload ready.
Copy. Going around the room, team. After this point, any system issue is a 3-word hold on the countdown net. If there are no concerns for flight, call go. Otherwise, call no-go. Red lead.
Go.
FTS.
Go.
GNC.
Go.
Athena.
Athena is go.
FAO.
FAO is go.
CDH.
CDH is go.
Tango.
Tango is go.
Astra Safety.
Safety is go.
Astra Flight is also go.
Alright, as you just heard, the teams have once again pulled go for launch. T-minus 8 minutes and counting. You can see right now that's the mission control team. Amanda, you want to give us an overview of the personnel that are supporting today's launch?
Yeah, so in the mission control pod, you see they're sitting here at our headquarters in Alameda. So in the bottom left-hand side of the screen there, you see Joshua Green. He is our controller, also the call sign Tango. His responsibilities are executing commands that are being called out for the ground support equipment, as well as the rocket and automation, and also just make sure that all the clicks and actuation are running properly. On the bottom right-hand side of the screen there is Jarrett Bullion. He is our command and data handling, our call sign CDH. And his responsibilities are just debugging some of the automation, monitoring progress, and looking for any anomalies in the launch system. In the back right there is our assistant flight director for today. He is in training. That is Derek Hamilton. He is hidden behind his monitors right now. But then on the far left is Chris Hoffman. He is our flight director for today. He leads the launch operations procedures and is ultimately our final launch authority. In addition to the launch operations team, we do also have an engineering backroom that helps to monitor the rocket, update software, and perform other various tasks during operations. These are generally the engineers that are responsible for the system elements, and they are there to ensure that things are working properly and to assist the launch operation team when troubleshooting if needed. And these folks are scattered across our facility at their own consoles. So huge thank you to this team. Launch operations is a multi-day effort with many checkouts and procedures that need to go perfectly in order to give our team the okay to launch.
I believe also in addition to those here in Alameda, you do want to go over the folks that are out at the launch site for today's mission.
Yeah, so we also have our red team. The red team are the folks on the ground in Cape Canaveral. These are the field engineers that travel with the rocket, and they provide on-site support during the delivery, the setup, and all of the final pre-launch preparations for the vehicle. They're basically responsible for all of the physical work that needs to be done on the vehicle after production has officially handed off the vehicle and launch system to launch operations. So basically find and debug all the mechanical problems. So Adam Fish is our red lead. He is the pad leader that has the final say on things, the pad itself, and leads the activities at the launch site. Then we have our red 2 through 4 members. It's Eric Larson, Corey Beals, and Benjamin Barrow, and they're responsible for just doing a lot of the assembling and troubleshooting of the mechanical and electrical tasks at the launch site. Then we have Melissa Cornelius, who is our Astra Safety Officer. Their responsibility is ensuring a safe launch, so that requires a lot of coordination between the range, FAA, and internal Astra personnel. And then we have Eric Steinberg, aka Steiny, as our red IT. He is our on-site IT and network professional that basically ensures that our cameras, communication, and data at the launch site is working. And as we mentioned earlier about hiring, there are positions on our career site for launch field technicians if anyone is interested in traveling to our sites and helping us assist with our launches.
All right. So coming up on the T-minus 5-minute mark, we're going to go ahead and listen in to the mission controllers as they work through the final few minutes of the countdown. Again, if you're just joining us, we are 5 minutes away from the next launch attempt for Tropics Flight 1 on Astra LV0010. Let's listen in.
Minutes.
T-minus 4 minutes and counting.
Rock, flight on countdown.
Rock.
At this time, can you verify range has restarted telemetry recordings?
Telemetry recorders are running.
You can see some of the teams here in Alameda gathering to watch today's
Reminder,
launch.
control room, if you require RF data in flight, be prepared to switch over your pages. MIFCO, flight on countdown, please be prepared to issue option when rocket IIP marker passes min-MECO marker and is within dispersed trajectories, calling out at event.
MIFCO copies.
Reminder all that any 3-word hold call from here on out will be on abort. ACE, please start PSD recordings and downrange ground station recordings.
Done.
Minutes.
T-minus 2 minutes, also some go so far.
Seconds. 60 seconds. Vehicle is on internal control.
Less than a minute to go. Everything looks on track.
First stage LOX tank coming to liftoff pressure. First stage fuel tank coming to liftoff pressure. "30 seconds. "20. 15. 10. Water on. 8, 7, 6, 5, 4.
Chamber pressure is nominal.
Our next objective is max Q, which is the period of maximum dynamic pressure on the first stage structure during flight, which is coming up just after 1 minute.
There's a tracking shot of the rocket ascending from Cape Canaveral on its way to space. You can keep track of the mission with the timeline on the bottom, as well as live telemetry on the bottom right of your screen.
Milestone is going to be the main engine cutoff, which will be called out by launch ops as NECO. Once that option is confirmed, the commander is set to shut down the 5 first stage engines and allow the vehicle to briefly coast. We will then signal to pop open the fairings and allow those to fall away from the vehicle. The first stage will then release upper stage for the final segment of our flight.
Two and a half minutes in the flight, again coming up on main engine cutoff at just about T+3 minutes. Everything looking good so far.
Flight, MIFCO, option sent.
Confirmed, option received.
Now looking at an onboard view, looking up, there you see payload fairing separation. This is a camera on the upper stage. And there's stage separation and ether ignition, upper stage ignition. Now the upper stage will burn for just about 5 minutes on its way to low Earth orbit. Again, everything looking good so far. Can actually see from the onboard telemetry the vehicle is actually already in space. However, it has to get that horizontal velocity needed to stay in space via achieving low Earth orbit. And so we're going to be watching that velocity marker tick up on the bottom right of your screen. But 4 minutes into flight, everything is looking good so far. You can see on the left there the path that the rocket has traced so far on its trajectory, pretty much due east right down the center of that corridor. 5 minutes into flight, everything looking good. And we're going to expect this burn to continue until about 8.5 minutes after liftoff.
Yeah, the 8.5 minute mark, that's when we will receive the second engine cut off, and at that point will be payload deployment. And just as a reminder, we should only be able to see one of the two payloads deploy from this mission from our onboard upper stage camera. However, it is likely that we may not see this video feed and we may not receive signal confirmation of the satellites for up to 90 minutes after deployment occurs. Again, this is completely expected, and it is due to the location of those satellites in orbit relative to their ground communication links.
Yeah, we'll have to wait and see exactly what we see there, but hoping to get some cool views. The teams at Alameda watching on as the flight progresses. Again, the flight going well so far, 6 minutes into flight. You can keep an eye on that altitude. You can see the rocket already over 510 kilometers in altitude. Again, the target orbit for today is at 550 kilometers in altitude. And you can see also that velocity continuing to climb towards orbital velocity, of course, which is good. 7 minutes in the flight. Just a little over a minute left in the planned upper stage burn.
Hey, Michael, they would like to cut back to the
We had a nominal first stage flight. However, the upper stage engine did shut down early and we did not deliver our payloads to orbit. We will end the broadcast here and thank you for sticking with us today.
Thank you to Astra for partnering with NASA Spaceflight to help bring live launch coverage to you, and stay tuned for more news coverage. But that wraps up our coverage for today. Thank you all for watching.
$20. 15. 10. Water on. 8, 7, 6, 5, 4.
Ascending from Cape Canaveral on its way to space. And keep track of the mission with the timeline on the bottom, as well as live telemetry on the bottom right of your screen.
Milestone is going to be the main engine cutoff, which will be called out by launch ops as NECO. Once that option is confirmed, the command will be set to shut down the 5 first stage engines and allow the vehicle to briefly coast. We will then signal to pop open the fairings and allow those to fall away from the vehicle. The first stage will then release upper stage for the final segment of our flight.
Two and a half minutes in the flight, again coming up on main engine cutoff at just about T+3 minutes. Everything looking good so far.
Flight, MIFCO, option sent.
Confirmed, option received.
Now looking at an onboard view, looking up, there you see payload fairing separation. This is a camera on the upper stage. And there is stage separation and ether ignition, upper stage ignition. Now the upper stage will burn for just about 5 minutes on its way to low Earth orbit. Again, everything looking good so far. can actually see from the onboard telemetry, the vehicle is actually already in space. However, it has to get that horizontal velocity needed to stay in space via achieving low Earth orbit. And so we're going to be watching that velocity marker tick up on the bottom right of your screen. But 4 minutes into flight, everything is looking good so far. You can see on the left there the path that the rocket has traced so far on its trajectory, pretty much due east right down the center of that corridor. 5 minutes into flight, everything looking good. And we're going to expect this burn to continue until about 8.5 minutes after liftoff.
Yeah, the 8.5 minute mark, that's when we will receive the second engine cut off, and at that point will be payload deployment. And just as a reminder, we should only be able to see one of the two payloads deploy from this mission from our onboard upper stage camera. However, it is likely that we may not see this video feed and we may not receive signal confirmation of the satellites for up to 90 minutes after deployment occurs. Again, this is completely expected, and it is due to the location of those satellites in orbit relative to their ground communication links.
Yeah, we'll have to wait and see exactly what we see there, but hoping to get some cool views. The teams at Alameda watching on as the flight progresses. Again, the flight going well so far, 6 minutes into flight. You can keep an eye on that altitude. You can see the rocket already over 510 kilometers in altitude. Again, the target orbit for today is at 550 kilometers in altitude. And you can see also that velocity continuing to climb towards orbital velocity, of course, which is good. 7 minutes in the flight. Just a little over a minute left in the planned upper stage burn.
Hey, Michael, they would like to cut back to the
We had a nominal first stage flight. However, the upper stage engine did shut down early and we did not deliver our payloads to orbit. We will end the broadcast here and thank you for sticking with us today.
Thank you to Astra for partnering with NASA Spaceflight to help bring live launch coverage to you, and stay tuned for more news coverage. But that wraps up our coverage for today. Thank you all for watching.